Hi, my name is Keith Tenzer. I'm a solution architect with Temporal Technologies. And together with my colleagues CC Thompson and Anthony Wong, we built a trivia game on Temporal to show what an amazing, awesome platform it is for application development. What we wanted to walk you through was why we chose a trivia game, some of the requirements we thought about, why Temporal, we want to play the game, and then we wanted to end it with kind of a review of our design. So why a trivia game? Well, obviously games are fun, but we like the idea of a trivia game because it's interactive. And we wanted players to interact in a meaningful way directly with temporal features and capabilities so that they could basically be playing the game and understanding and feeling the capabilities that temporal is actually providing under the hood. So hopefully we achieve that. When we sat down to discuss how to build this, we essentially set out to build something similar to Jackbox games, if you're familiar with that. Anyway, we wanted to scale to millions of users, support multiplayer, build it using a polyglot, i.e. multiple programming languages, have the state of the game be durable, have a mechanism for a timer mechanism for questions, have a single source of truth for the game logic, so not keeping the UI clean. We didn't want any game logic in the UI, and we wanted to do all this in a couple hundred lines of code. So you're probably thinking, that sounds like a pipe dream. And that's where Temporal comes into play. So the first part was we decided to design the game, each game, as a workflow. Because Temporal can scale to billions of workflows, that means we can have billions of games. So that solves the first part, a problem right off the bat. It's built in. Next, we wanted the game state to be durable. Again, that's built in by Temporal, and you'll see that when we play the game. Timers, again, they're built into Temporal. We're using asynchronous and synchronous timers for this game. We wanted it to be programming language agnostic, as we wanted to write the UI in Node.js and TypeScript, and then have the backend be in Go. Again, that was seamless. And then we interact with ChatGPT in order to generate the questions. So that can be quite unreliable, as it's an unreliable API. But also you can have a different number of questions, so there's no way to know how long it's going to run. It could run for a while. And so retries and heartbeats are really important to ensure we don't make players wait for no good reason. And then we have an interesting scoring system for the game. So if you're the first person that answers a question right, you get 2 points, and the second person, or everyone after that gets it right, gets 1 point, otherwise 0. And so we needed to understand ordering. So the first person that responds correctly gets 2 points. And that's built into how signals work in Temporal. So signals are ordered. So basically, yeah, we didn't have to do anything. And then finally, the real kicker here is workflows. You can interact with them, right? So the state machine that we're maintaining in the workflow, we can query that from the UI, and that's what progresses the game. And then as players give their answers to questions, to the UI, we simply signal that into the workflow, which then updates the state and progresses the game. It's all really simple, but really awesome and interesting under the hood. All right, let's check it out. So I'm gonna open up a couple windows here. On the left, I have actually the Temporal Cloud UI, where we can look at what the game looks like from a workflow perspective. On the right, I have the game. And at the bottom, I have where we're running the workers, which are handling the workflow execution. So I'm going to start this game. I'm going to go into the settings. We configure a number of players. Sadly, I'm just by myself, so 1. I'm going to set the number of questions to 3. You can give it a category. You can set the question timeout, which I'm going to increase to 300, so we have some time to try to break things while we're doing this game. And then result timeout is how long we display the results of the questions. I'm going to set that to 10 seconds. Again, both of these use temporal timers. Okay, so I save that, and now all I have to do is open up my phone, and I'm just texting this 2150. That's going to be this iteration of this game ID that I'm starting to that number. You'll see my number pop up here. There it is, and I'm ready to start the game. And so when we start the game, this 2150 will also be the workflow ID. So now I'm going to start the game, and you're going to see it generating questions. So it launches an activity that talks to ChatGPT to generate the questions. Here you can see the workflow. We can just open that up and see here it went out to start that activity, and it's already showing me questions, so I know it got that activity completed. You can see here it's got a result, and actually we already have the questions and the answers, so we already know what we need to know to basically progress this game. And all of that is executing workflow-wise on across these pods here running in Kubernetes. All right, so what is the smallest country in the world by land area? So that's a tricky one. I would say it's either Liechtenstein or Vatican City. I'm going to go with Vatican City. I believe that's the right answer. Yep. So I got that answer correct. So I get 2 points. You'll see over here on the temporal side, it's on auto refresh. So it'll update kind of the workflow pretty soon. It's, I think, 15, 20 seconds. There it goes. And so you can see it set a timer here. That was that first timer for the question. Then it received the signal. I answered B, and then it basically progressed to the next question, reset the timer. So now I'm on the next question. What is the largest ocean in the world? And so here I think it's probably the Pacific. I'll just answer it wrong. Arctic Ocean, just for fun. You can see my answer popped up. It was wrong. You can see we got a signal received here. The game state updates, which then the UI is querying, and then it moves along. Okay, this is the third and final question. So we're going to do something a little more interesting on this question. So what we're going to do is we're going to crash all these workers. We're going to kill all these workers. So there's nowhere for Temporal to actually execute anything. So I'm going to basically scale this to replicas to 0, and this kills all those pods. And now if you think about it, we've got this game running, right? And there's clearly we're maintaining state in the game. We're not like writing to a database or anything. This is persisted in the workflow. And I've just killed the execution layer. So you would basically just think, okay, well, there goes your state, right? And that's the beauty of Temporal, is that it's basically, we have an event history, and all that state is being persisted at every step of the way. And so we can rebuild that state when these workers come back up. And so what we're going to do now is those workers are all dead. We're simply going to just showing you that there aren't any. And then we're going to answer this question: what is the capital of France? I'll answer this B for Paris. Correct. So now I've just answered the question, and you'll see a signal come in, because the workflow can still, even though there's no workers, it can still accept signals. But it can't progress the game, obviously, because we have nowhere to execute this. So I got the signal, but it's just going to basically be stuck here until I start up my workers again. So I'm going to do that right now, and what you're going to see is that essentially it's going to process the signal, and then it's going to update the state, and that'll update the UI, and the game will continue. And it's not going to lose any of the state. So the previous questions that I answered, they're all going to be there. Everything just goes on as if nothing happened. And so you can see here, Paris, correct answer, 0845. And you can see kind of updated here. We're at now the timer for displaying this result, which is 10 seconds. And then you can see it updated here to complete the game, which is the last thing we do is calculate the leader. In this case, there's only one player, me. So that's easy to do, but nevertheless, that's an activity. You can see the workflow completed, and we have a winner, and everything worked magically, right? And that's what Temporal does. And then the real amazing thing is, if we look at the code here, to do all of this, just bring up the code here, the workflow code, it's 200 lines of code, right? And and that's actually 100 lines of it is essentially just setting things up, setting up inputs and signals and things like that. The actual workflow logic starts actually right here on line 82, where we execute our first activity, and it completes down here at 182. So it's basically 100 lines of code. Just amazing, right? And I think until you actually code something like this and do it, you don't get a full appreciation for it. Anyway, that's how we felt. So just kind of review the design that we had and kind of what we showed. Again, there's two components to this. There's the front end UI and the back end. And so what happens is users connect to the UI via SMS. They join a game, start the game. That starts a workflow, and then the UI simply just queries the state of that workflow and progresses accordingly. And the backend then starts. It goes to ChatGPT via an activity, gets all the questions, and then updates the state. Game goes. Users answer questions. Those get signal to the workflow. It updates itself or updates the state. The UI progresses until the game is done. Again, beautiful separation of concerns here between these two components. There's no logic here. All logic is here, and it's just really clean and easy to work with. So, yeah, I hope this was interesting to you, and I thank you for your attention and time.